So I'd like to start talking about Chapter 9. We have talked to this point about expressions of equations which were called quadratic, and expressions and equations which were called rational. And the goal for Chapter 9 is to talk about expressions and equations which are given the adjective of radical. Now, this always puts me in mind of like 90s Kool-Aid guy busting through the wall, skateboards and cargo pants, but radical is a term which here will mean that it contains some kind of root, either a square root or a cube root or a root of a different variety. So to start Chapter 9, let's talk about exactly what is an nth root, and that's what we'll be doing today. All right, so just in case you have not heard these terms before, I know some folks have not, I want to talk to you about even numbers and odd numbers. So these definitions are just written here. An even number is a whole number that can be evenly divided by 2. An odd number cannot be evenly divided by 2. So something like 10 would be even, but 11 would not be even. Now, the definition of an nth root is different depending on whether you're dealing with an odd number n or an even number n. So let me start with the case that n is an odd number. If n is an odd number, the nth, the nth root of something called, let's just call it a, and here's the notation. It's written as square root symbol, with the number n written really small up here in the sort of elbow of the square root symbol, a underneath. The definition of this term is this is the number whose nth power is a. Now, scrolling down just for a minute, I'd like to test this out. Let's try and calculate the cube root, the third root of 27. Now, the goal here is to look for a number so that number cubed equals 27. And my process is just to sort of go through one by one and think about numbers and take their third power and see if the result is 27. So starting with 1. 1 times 1 times 1 is 1, so that's not going to work. So I'll move to number equals 2. 2 times 2 times 2 is 8, so still too small. But if I start to work with 3, and I do 3 times 3 times 3, I do 3 cubed, that is 27. So what I would say is that for the final answer, the cube root of 27 is 3. Why? Because 3 times 3 times 3 gives me 27 back. 3 cubed is 27. Okay. The definition is slightly different in the case where the number in the elbow of the root here is not an odd number like 3, but an even number, maybe like 4. If n is an even number, the nth root of something that I'll call a, it's written exactly the same, nth root of a, is the non-negative number whose nth power is a. So I'm going in and I'm making a specification. I'm going to say that by the definition, by the construction of the meaning of this symbol, this nth root of a can never be negative. I'm only allowing this to be 0 or higher. So let's look downstairs here at a particular example. Let's say 4th root of 16. My goal is to calculate this. So I'm thinking about numbers whose nth power, or I should say whose 4th power is 16. But there's an issue because I can think of two numbers whose 4th power is 16. 4 times 4, or I should say 2 times 2 times 2 times 2, 2 multiplied by itself 4 times results in the 16, which is under the root here. However, negative 2 times negative 2 times negative 2 times negative 2, if I multiply negative 2 by itself 4 times in total, the result of that is also positive 16. Since there are two numbers whose 4th power is 16, which one of them should I choose to be the 4th root? Take a moment, what do you think? The 4th root is non-negative. The 4th root is not allowed to be negative. So that automatically disqualifies negative 2 from being the result, the simplification of 4th root of 16. Now we're going to simplify and calculate the value of 4th root of 16. That is positive 2, non-negative. Okay, so for even roots, never negative. For odd roots, you can do whatever you want, as long as the number's nth power is a. Now, just a little bit more terminology. It becomes really inconvenient to refer to n and a as the number in the elbow and the number in the root. So we're going to get some official terminology for these. The index is the official term of the number in the elbow of the root, the little one here, n, and the official term for the quantity under the root, what we call a, is radicand. We call that the radicand. So let's just do a few more examples here. Let's consider what would happen if we had a root with an index of 3 and a radicand of negative 27. Negative 27. Can you think of a number whose 3rd power is negative 27? Now, I think in order to get an odd result, I'll need to start with an odd number. Now, I know that positive 3 to the power 3 is 27. So I'm inspired to consider, what about negative 3 cubed? Negative 3 times negative 3 times negative 3. Well, 3 negatives, in total negative 27. And so that would be my final answer here. The negative 3 I would choose as the result of this odd root. Negative 3 to the 3rd power equals 27. Remember, odd roots are allowed to be negative. Only even roots must be non-negative. All right, final example. Let's consider the 4th root of negative 16. Can I think of a number whose 4th power is negative 16? Now, my first inclination is to try maybe negative 2, because I remember that positive 2 to the 4th power was positive 16. So maybe negative 2 to the 4th power would be negative 16. Unfortunately, though, if you multiply negative 2 by itself 4 times, all the negatives will cancel out in pairs. Negative 2, that's positive. And in the back, negative 2 is positive. Now, because of this phenomenon of negatives canceling out in pairs, you're actually never going to be able to find a number whose 4th power is negative 16. So it's not possible I should say, not a real number. It's not possible to find a real number that this is equal to. That would be my final answer for this part. Now, one last warning. So back in the day, we had this symbol square root, which was written as just this radical symbol, just this crooked symbol here, with no number in the elbow here, no apparent index that was visible. Now, what is implied when there's no index is square root is an index of 2. I know it's tempting to see this and say, oh, that must be an index of 1. But we never, ever, ever talk about the first root of a. You can rest assured that you will never see anything that means the first root of a. Square root is the same thing as second root.